In this video, we will learn about mesh analysis. So the objective of the class of this video tutorial is to solve a circuit analysis using what we call mesh analysis, which is basically the application of Kirchhoff voltage law, or known as KVL. So let's start with an example. Imagine if you have a circuit like this. So you have a voltage supply called US1 connected to several resistance in this configuration, and then there is another loop on the other side where you have another voltage supply and also another set of resistances. Let's say I'll call this second voltage supply as US2, and the resistances are called R1, R2, R3, R4, and R5, right? So you have a circuit with two mesh on the left and on the right side. You have two power supply, US1 and US2, and you have 5 resistances connected in such configuration. So the objective now is, how do we solve this circuit? So let's say all US1, all the resistances, and US2 are known. There are several other parameters that are unknown that we need to find out. For example, the most obvious one would be the current that circulates in the first mesh, the current that circulates in the second mesh, and the voltages that goes across all the resistances R1 until R5, right? So how we do this? How do we do this? If you want to use mesh analysis is basically the application of KVL. So if we want to use KVL, we have to remember that KVL is a law that's applied on voltages, and it needs you to identify what are the loops, right? What are the loops or the meshes. So let's say the first step would be to start with the first step, which is we have to identify the meshes, right? So how many meshes do you have here, right? If we take a look, there is basically 2 mesh. And then when you found out the mesh, you have to assign the direction of current in each mesh. So you have 2 mesh, right? You have the first mesh over here. I will call it as mesh A, and second mesh is here, which is mesh B. And second step would be to assign the direction of current in those meshes. So assign current direction in mesh. So how do we assign this current in these meshes? It is arbitrary, so you can decide whatever direction you want to choose, because later when we do the calculation, it will recompensate, it will recorrect itself, right? So the usual practice is to take a clockwise direction. We say that current IA circulates in this mesh in a clockwise direction. So this is current IA that circulates in this mesh. And then there's another current that circulates in this mesh, also in arbitrarily I choose clockwise direction, and this is the current I assign as IB. So we have assigned direction of current. Next, once we have assigned direction of current, what we can do is write the KVL, right? So the third step would be writing the KVL. So if you want to write the KVL, what you need to know is, we know that from previous classes, is we have to first identify the voltages. Where are the voltages? And then not just identify the voltages, but also identify the polarity, or actually direction of the voltages, right? So how many voltages are there in each loop, and in which direction do they point to, right? So for example, let's take the first loop. So I'll write with another color now, blue. So in the first mesh, we have the first voltage, which is US1, and then you have the current that circulates in clockwise direction. So for a load, the current is always opposed the direction of the voltage opposed direction of current. So you have UR1 in this direction, and then if we go to R4 first, let's go to R4. In R4, UR4 will be in this direction. Okay, now there's a particularity on R3. R3 is basically affected by two currents. If you look at R3, right, so I'll highlight R3. If you look at R3, R3 is affected by two currents. It is affected, there is current that comes from IA that goes across it, and there's also current from IB that goes across R3. So now, in first mesh, what we do is we assign the direction of voltage that is affected by current IA. So voltage that's affected by current IA goes in this direction, it opposes the direction of current. So we call this voltage as UR3, but UR3 due to the current in mesh A. So UR3A, right? I call it UR3A. So there's three voltages, US1, UR1, UR3A, and UR4, right? So let's go to the second mesh. In second mesh, so we have the voltage, so the battery and the voltage supply give already the direction of its voltage. So it is in this direction. And for R2, UR2, so it opposes the direction of the current. So this is direction of UR2. And R5, it opposes the direction of current. So this is direction of UR5. And for UR3, there is a voltage that is affected by IA and IB. So in this part, we will assign the direction of the voltage that's affected by IB. So it is in this direction. I call it as UR3B. Right? So if you see at R3, there is two voltages that is in opposite direction. There's one voltage which is UR3A, and the second voltage is UR3B. So these are all the voltages that have been identified and have been assigned with direction, right? So what would you do? What do we do next? Now you can write the KVL, right? Apply KVL. So let's write the KVL together. So apply KVL. So there is two mesh. We have identified two mesh. So there will be two equations of KVL. So the first equation due to the current in A. So let's write down the equation. So if we go through the mesh in the direction IA, you'll see that you have US1 minus UR1 minus, so the voltage in R3, it is UR3, right? But it's not just UR3, there is UR3 and A and B as well. So it's minus UR3A, right? And then plus, or so now the sign become minus UR3B. And then finally you have minus UR4 equals to 0, right? If we rewrite everything in where we put the power supply on one side and other voltages on the other side, you will get US1 equals to, so UR1 plus UR3A minus UR3B plus UR4, right? So now we don't know what the values of the voltages are, so we have to develop it using Ohm law. So if we rewrite everything, but that in developing them using Ohm law, you have UR1. What is UR1? UR1 is R1 multiplied by IA, right? Plus UR3A and UR3B. What are they? They are basically the product of R3 multiplied by IA minus IB, right? And then UR4 is R4 multiplied by IA, right? So now we have an equation where you have the known parameters, which are US1, R1, R3, and R4, and two unknowns, which are IA and IB. So let's go to the second equation due to KVL on B. So on B, what we can write is we have, if we go through the loop, you have a minus US2 minus UR5 minus, so UR3, there is two component of UR3. There is minus UR3B minus UR3A, and then the final voltage is minus UR2, right, equals to 0. And if we rewrite it in a form where you have a voltage supply on one side, you'd have minus US2 equals to UR5 minus, no, it's not minus anymore, it's plus UR3B minus UR3A plus UR2, right? And now we don't know what the voltages are, so we develop into terms with known parameters, which is the resistances. So US2 equals to, so what is UR5? In second mesh, it is basically R5 multiplied by IB plus the term of UR3B and UR3A. They are basically the product of R3 multiplied by IB minus IA, right? And then finally R2 is R2 multiplied by IB. So we have two equations. So I'll highlight the equations. We have two equations from KVL in mesh A and from KVL in mesh B. So these are the two equations with two unknowns, and the unknowns are IA and IB, right? So when you have two equations with two unknown, what you can do is you can solve the system of equation, right? And by doing so, you will find what is the value of IA and what is the value of IB. So what we can do is I can let you solve the equation, or what I usually like to do, what happens usually, you can do comparison of the two equations to find out what IA and IB is. But the usual way to do, a better way to do it, to be able to later computerize the calculation, is to put them in matrix form. So the matrix form means, so in fifth step is solve the equation. So I would like to put it in matrix form. Matrix form means putting it in a form of, in Ohm law, where you have one matrix of that regroup the resistances multiplied by the matrix that regroup the current equals to the matrix that regroup the voltages. So if we do it for our system, you'll have a square matrix of the resistances multiplied by a column matrix of the currents. The currents is the parameters that is unknown, which the one that we're looking for, IA and IB, that will be equal to the voltages that we put on the other side, which was US1 and minus US2, if you go back into that equation, right? So what are the parameters of the resistances in the matrix? So we have, if we look, the first line of the matrix will come from equation A, and the second part will come from equation B. So what is multiplied by IA? If we look into the first equation, we have R1 multiplied by IA, R3 plus R3, and plus R4. So it's R1 plus R3 plus R4. And what is multiplied by IB? That is minus R3. In the same case for the second equation, what is multiplied by IA? We have only minus R3. And what is multiplied by IB? We have R5 plus R3 plus R2. So it's R5 plus R3 plus R2, right? So if so what you need to do now is, in order to find IA and IB, IA is equal to the determinant of matrix A over the determinant of the system of equation, and IB is equal to the determinant of B over the determinant of the whole system. So what is the determinant of the system? The determinant of the system is the product of R1 plus R3 plus R4 multiplied by R5 plus R3 plus R2 minus R3 multiplied by minus R3. So this is the determinant of the system, and the determinant of A and B. So this is what we call Kramers Rule. So I write down over here, it's Kramers Rule. You can refer to it later. So usually we have learned it before in math. So what we need to do is just the application of it. So I'll just remind you, so what determinant of A is. So the determinant of A is basically when you replace the solution on the right hand side into the first column. So the determinant of A equals to, when you do the product of US1 multiplied by R5 plus R3 plus R2 minus US2 multiplied by minus R3. And the determinant of B is when you replace the second column with the solution of the system, the right hand side of the system. So it is R1 plus R3 plus R4 multiplied by minus US minus R3 multiplied by, so here it's US2 multiplied by US1. So when you do the calculation, you'll find what IA and IB is. So let's say I'll let you try. I'll give an example. If US1 equals to 10 volts and US2 equals to 5 volts, while R1 equals to 1 kilo ohm, R2 equals to 3.3 kilo ohm, R3 equals to 1.5 kilo ohm, R4 equals to 2.2 kilo ohm, and finally if R5 equals to 4.7 kilo ohm, this will result in finding IA equals to 2.06 milliampere, and result for IB will be minus 0.2 milliampere, right? So you try to solve the equation to find, with this parameter, to find IA and IB equals to these answers, right? So that's how we solve a circuit analysis using mesh analysis. So the first step is to identify the mesh. Second, assign the direction of current in each meshes. So it is arbitrary. And the third is to apply KVL. To apply KVL, you have to identify the voltages and identify the direction or the polarity on each components of the mesh. And then you apply KVL, write down your KVL, and finally solve the equation. So just a remark, if you look at the value of IB, it is minus 0.2 milliampere. It is minus 0.2 milliampere. It means when we decided at the beginning the direction is clockwise. So when we do the calculation, it shows that actually the direction is not clockwise. The current actually goes counterclockwise. So that's why it is not important how you assign the direction of current in the beginning. You can assign direction of current arbitrarily, but once you solve your equation, it will recompensate and correct itself, and it will tell you the correct direction of that current, right? So that's all for mesh analysis. I hope you do the exercises, try to do the exercises in the slides. There are exercises where you have more than 2 mesh, you have 3 mesh. So you have a system equation of 3 unknown and 3 equation. So please try them, and I'll see you in next video for the next chapter. Thank you.